Okay.
I have no idea what event is occurring tonight. I just know that there is one.
Sport ball.
Hunger Games. That's a sport.
Don't confuse
No, it's a movie. Sorry. Well.
All right.
Okay. All right.
You guys want to inform us if you're better
Tell us.
educated about
I'm not against kicking sport ball.
Okay. Let's start this up. All right, Harry, how's it going?
Hello.
Show your project.
What's up?
Hey, so I had shown the dice roller thing earlier.
Oh, that's right.
And
The ultimate dice roller.
yep, and I'm back with an updated version where I've actually packaged it up nicely and I turned off my singers. So now it has an actual power switch, and it's all packaged up and
Super fancy.
and 7 and well, it's the same thing as before. You press all the different buttons.
Each button is for the different dice. Yeah, so you can do a D20, D4.
Yep.
Okay.
Exactly.
Right.
And better, because, warning, incoming statistics. I went and did some analytics on it. I went and hand-recorded 250 numbers. I just pressed the button 250 times. And this is the histogram that comes out of that.
Man, look at that science. Becky, look at that science.
Yeah. So
that's some pretty scientific science.
So the line there is where you expect them all to be if it's uniformly distributed. And that looks bad until you see this is the same thing. I used MATLAB for this.
Yeah.
This is what it looks like if you use the internal random number generator, which they claim is good.
Well,
so,
it's not going to be, if it was actually even, then it wouldn't be random.
Yeah, exactly. And so
because then you would know, you'd only be able to predict, like, oh, I haven't gotten like a 20 lately. I know I'm going to get one soon because it's supposed to be even when actually.
Yeah.
Statistics.
Yeah, exactly.
I expect that you'll get something.
I had to go brush up on my statistics.
Yeah.
And so this is the software, and then this is the hardware version. And then this is a manual printout of the program that I wrote to test it because, well, there's some internal things, but I didn't want to use them.
This?
Yeah, I used MATLAB.
Yeah, MATLAB, I cry.
The student, it's not as bad as Maple. My college forces me to use Maple for everything, and Maple is the most devil spawn software I've ever used in my life.
we had to use MATLAB, and there were many evenings of like, oh my God, nothing's working anymore. What happened to my data? Oh wait, it's okay now. Wait, everything's totally messed up.
Yeah,
wait,
no.
It's okay. Like every hour, like up and down.
It's nice sinusoidal, kind of this sinusoidal mood of while playing with MATLAB.
And I'm already getting like a fever thinking about I'm really glad I don't have to do MATLAB.
Yeah, and so I did the statistics test on it, the results, and it's like the p-value was like 0.92 or something like that. So well within the range where we can't reject the hypothesis that the data was uniform.
I thought it had to be 0.95 or higher for it to be, because it's to be a
other way round, I think, because we're rejecting or not rejecting the null hypothesis that the data is uniformly distributed.
So wouldn't that be 1 minus point? Oh, it's 0.5.
So it would be so it would be 0.05 other way around. So it has to be greater than 0.05, and it's like 0.92. So
okay. Good enough, close enough.
Yeah.
You are now the PI of dice rolling.
So yeah, so I'm kind of going to finish packing this up.
Okay.
Stealing a trick from you from the TVB gun kit where you use the double-sided foam to stick everything down. I'm probably going to do that, and then it'll be done.
Good enough. Great.
I have one question. So you said the random number generation. You're not using what's in the chip. You're doing something else. Or you are using what's in the chip?
No, I'm not using the stuff that's in the chip. This is all hardware based on the noise off of a Zener diode. And it's actually all taken from someone else who had done this, and I borrowed his designs. Leon Marr, University of Wisconsin-Madison. He's awesome.
Backed by Zener diodes are like mega messy.
I knew the answer. I just was leading you on so other people would watch this, yeah.
Yes. No, I'm not using it.
It's as if we planned it.
There's a Zener diode back biased in the wave bubble to generate noise as well.
Yeah.
Although, honestly, it's pretty noisy. Didn't really need it.
I actually think this is a neat tip because a lot of people are making their own electronics and they rely on random number stuff, and to use what comes on the chip won't be as good. And this is a neat. It's not even a hack. I would say it's just a good technique. Hack would be different. Do you think this is a hack or do you think it's a technique?
This is a technique.
This
is a documented technique.
This is something that they use in the real world too. Like if you get a crypto chip that's all of us on a big chip, all shielded and everything.
Okay,
it's all
quick
legit.
quiz. What classification is the noise that comes from the Zener?
Ooh.
I actually don't know.
Okay.
Is it thermal noise?
Huh?
Is it thermal noise? It's generated.
I know that it's not Johnson noise because that comes from.
Oh, you don't
sisters.
even know.
No, that's like
This is
the
your question.
quiz.
Oh, I see.
Question? I don't know. I want to know.
No,
I don't know offhand.
All right, next week you have to come back. Tell us the classification of noise that comes from Zener diodes.
Maybe we'll make this a trivia question. So if anyone's watching now,
That's a damn good
We'll do the classic job interview thing where you say I don't know, or you don't say I don't know. You say I'll get back to you on that.
Right. You can say what it isn't. You'll be like, oh, well, I know it's not like this. Yeah. But it's interesting. I don't remember exactly why, but Zener diodes are extremely noisy sometimes. I don't know.
Okay. Well, thank you so much, Harry. Another excellent show and tell.
That's cool. I would love to see a write-up about this, too. This would be a super
He has blog access. He can write it up.
Oh, right.
I didn't know if I wanted to use my blog access to, I don't know.
Yes.
Self-promote. Self-promote.
All right.
Yeah, absolutely. Yeah, feel free.
a tutorial.
Yeah, do it up.
Yeah, right now.
Add the little technique.
It is very, very handy because people are always asking how do they, because they're like, oh, I'll use a Geiger counter. And I'm like, well, you don't really.
That's really expensive.
Yeah, it's expensive and rare and delicate when you can use a 5-cent part.
Total BOM cost on this, not including the case, but just the total BOM cost of the electronics is like $10, including the LED screen.
Yeah.
That's expensive.
That's less than a set of dice.
Yeah.
Yes.
Probably. That was the hope.
Cool. Yeah, make sure when you write it up, compare, like go to an online site and put all the dice in the shopping cart and compare versus your electronics.
The only thing is you don't get to you can't stick this in your chainmail handmade dice bag. No, because it'll short out. You have to.
Epoxy the thing. Just dump the entire thing in epoxy.
Oh right, I forgot. You can put it in your velvet lined chainmail dice bag.
Yeah.
You can tell what I did in high school.
Yeah, times have changed. We're now using electronic dice.
Okay.
Okay.
Awesome.
Well, thanks so much, Harry. Okay, next up, we're going to do Kevin and then Jeremy.
All
Kevin.
right, checking in.
Oh, hey, Kevin.
Hi, yeah, I'm just checking in. A couple things. You're probably all bored with the boot drive by now, but I added one thing that I thought was kind of cute is that it now can record. So, like, you put it into record mode, and then you just program it from the Arduino IDE, and it captures that. It has auto reset turned off so that it can just read the serial port. And the way I did that was I basically just lifted the code from OptiBoot and stuck it in the sketch, and it works great. And
does it record the hex file, or what does it record as?
So it actually, I thought about converting it to hex, but then I just decided I was lazy, and I just sort of recorded it as a binary file. And then my routine, which was programming the hex file, I made it. So there, I just did it. I just recorded it.
Yeah, done.
Done. So and the backlight changed. When you're scrolling through the files, it detects whether it starts with a colon. If it starts with a colon, it uses the hex decoding, and if it doesn't, it assumes it's a binary file and records it that way. I'm working on taking your code from the Ada loader so that I can actually use ISP programming, because this is sort of limited to FTDI kind of based Arduinos unless you hook the wires right up. I think it's going to be fairly trivial, but there's a lot of crunching down to get it all to fit, because it's mostly debugging code. All the serial prints and stuff like that take up a lot of space. So I'm taking that out. The other project, which I haven't started yet because I made a mistake when I ordered your fingerprint reader and got U.S. Postal Service shipping, so I don't have it by now. But
no.
It was a mistake. Actually, I'll send you an email about your shopping cart. But I wanted to. I don't know if you've already done this, but I have an application at work where I need to use the fingerprint reader for the Linux application, and so I got one of the FTDI breakouts, and I'm going to hook it up to the fingerprint reader, and then write a Python library for it so that I can.
We haven't done that, but it should be really easy if you take the code the Arduino library code.
Yeah, that's what I was trying to do.
You only have to change like the serial read stuff and then Pythonize it because it's all weird with lists and stuff. It should actually be pretty easy. In fact, easier because you don't have to deal with stupid like buffer timeouts like you do with the Arduino because it's so limited. But there's no reason you couldn't hook this up to any kind of computer with a serial port. That's why I like it's a UART. I mean, yours are a little annoying for Arduinos, but it's fantastic because you can just plug it into any computer.
Sure. Yeah. No, I think it's great, and you know, it looks like you did a good job with the library and saved me the trouble of trying to get the data sheet translated.
Yeah, don't even bother. But the demo program works really well. So you know actually what I did is I ran the demo program.
Oh.
I just grabbed. I don't even bother reading data sheets anymore.
You just
If it
snipped
comes
it.
to the demo program, I just dump the data directly as is what it's sending and what's receiving, and then I correlate that to the data sheet, which works way better than trying to go by just the data sheet because the data sheet's usually wrong. I mean, like, it's just not. It's not meant for the products that we're starting to get, like the fingerprint module and the camera module. These are meant for industries where it's like there's one customer.
They're not writing software for it.
They're not. Yeah, there's like one customer, and like these are like what's left over from like the big customers.
Yeah.
So these fingerprint sensors are meant for safes. They're not meant for like, hey, hook this up to your propeller. It's just that's not what the
Right.
best sensors are for. It's just fine because like we'll get it working,
Yeah.
and they're easy to use. But it is kind of an interesting, especially like when it's not just a chip anymore, but an actual module. There's something that happens where suddenly the documentation just falls off a cliff. Like that.
All right.
Cool.
Okay. Well, thank
So
you.
I'll let you know if I get something together, and
Yeah.
you're welcome to have it.
We'd love to
Yeah.
test it because people ask us all the time what they want to.
One of the reasons we do open source is because we're not going to be able to get to everything. So if we
Yeah,
put stuff
sure.
out there, we hope someone can come along and fill in some of the gaps.
Cool. All right.
Okay, great.
So we're going to wrap up with Jeremy and then Robert. So Jeremy, show us your project.
Hi guys, this is basically just Lemur's work on the eye charging thing. All I did was made this little guy, and then I discovered Dorkbot PDX service, and so it went
Whoa.
little boards made.
Uh-huh.
So
Then
it's
you
just
put-
a breakout with the resistors.
It's just, all it is it's stupid simple. It's 4 resistors, and then this one has a little SMD LED on it.
It's pretty handy though. So you
It
just
actually
plug
is
in
very good because you
4
can
double
charge.
A's and.
I have a lot of guys who ask me on my blog questions about charging an iPad. It's like one of my most I did a little post on it, and it's one of the most popular posts. And this will do the trick if you're trying to take iDevices and charge them outside of buying a $30 Apple charger. This is the simple way to do it. So I took your schematic and then I just put it on a board, and then I'll see if anyone wants these things. But it's actually very handy because now you can put these things everywhere. So
I'm starting to see people like this. If I could buy stock in like Lane's PDX board service,
Yeah.
I could, because like it's like totally changed how people do their PCBs. It's like the most popular PCB service.
And the interesting thing, because from behind the scenes, there is a swarm of like PCB makers out there that are constantly trying to spam our blog and do kind of rotten stuff.
They should just like have something as cool as this
They should
one.
just do a really good job.
If they had a really cool
Well,
color,
everybody would
if they had a
do
color that was different, like there's a lot of colors that are not used for PCBs. Everyone
Yeah.
would know because when I see purple boards, I'm like, oh, it's like
They-
a Lane board.
Yeah, it's great.
Brilliant.
And they're not spamming blogs. They're not trying
me
to
too.
to deface wikis. They're just doing an excellent job for makers.
Yeah.
Go figure.
Yeah.
It's a business.
yeah, that's actually really true. I actually woke up the other morning and I was kind of, I wouldn't say bored because I had a lot of stuff to do, but I just threw this together in like a few hours, and it cost me under $5 for 3 of them. So I was like,
Wow.
hats off to him
What's
for.
what's the lead time? When you're done, you send the boards out. The files. How long does it take you to get it back?
I sent them out on the 9th, and I got them. I emailed them on the 9th, and I got them today, I think.
Okay.
That's not
So-
bad at all.
3
It's
weeks
not too bad, yeah.
for
Yeah.
$5. I mean, like that's
$5.
pretty cheap.
That's great.
That's great.
That's cool.
And it's $5 per square inch too. So it's not. It's if you'll leave it out there, it's $5 per square inch. These are pretty small, and so that's why it costs that
I
little.
can't even imagine. Does he have a job still, or is this?
I don't know. I should probably write a make article and just say how awesome this is, because I'm literally about to call up a company to tell them to stop trying to spam our blog and wiki.
It's really out of control. They're
like
usually.
these like PCB houses.
It's actually not even a PCB house. It's a person who gets money by generating leads for
Yeah.
PCB houses. It's like not. It's just fake reviews. They keep posting fake reviews.
Yeah. I want to write an article about the right thing to do, because it'd be great if all these other places started to help out makers and do this.
Nice. Cool.
Okay. Well, thank you so
Awesome.
much, Jeremy.
Thank you, Jeremy.
Cool project. Oh, and feel free to send us a link about this. We'll post it up when
Sure.
when you're ready.
I'll put something up.
Okay.
Okay, awesome.
All right, Robert. Hello, Robert.
Hello, Robert.
Hey, how's it going?
Yo. How's it going? You're going to show off some of your... What have you been working on lately? You were working on some...
Well, I've been...
LED stuff.
The most recent thing that I... Sorry?
You were doing those LED things last, right? The little LED strings?
Oh, yeah, the hacking the Christmas lights.
Yeah.
Yeah, that was a fun project. I have some on the wall here, but they're not... it's not quite what I was going to show off today.
Let's go.
Oh, real quick, but for the folks who've tuned in and don't know the history, maybe you can explain. You guys worked on a project.
Yeah, we worked on the Y-Box,
Yeah.
which is our propeller TV Internet of Things.
One of the coolest, one of the coolest examples of propeller, I think.
It was actually one of the first propeller kits,
Yeah.
from what I know. It actually had really good use of the propeller.
Yeah, Parallax is going to be here in 2 weeks, and so we're going to give them a tour. We're going to show them our Parallax section here. So anyways, just wanted to give that a little bit of a shout out.
Okay.
Well, actually, the Christmas lights that I got set up, I actually have, they run off of a Y-Box too, just because it's it happened to be the easiest thing to use at the time. So the most recent project that I had been working on was, since I had a house, I wanted to like have some sort of feedback loop for like the, you know, if the soil's wet, you don't want to water the lawn, right?
Yeah.
And so I got this idea that I wanted to capacitively sense like if the soil was wet or not, because resistively sounded like it would have corrosion problems over time, and eventually I'd run into all sorts of problems. So I came up with this basic idea. I don't know if you can see the pattern on there. It's got basically a sensor on it, and it's got an AT-Tiny on it. Here's a slightly different model. And it's super simple to build. And I tested it on some potted plants, and it seemed to work okay. Ran into some problems with what I was covering the circuit board with, ended up absorbing some water, which ended up changing the capacitance quite dramatically. And eventually, I started sticking some more of these in the ground, and then I started realizing that I had run into a problem, which is that I wasn't isolating the two. Basically, it was the ground plane is one of those lines, and then I'm sensing on the other plane, and then when you stick another one in the ground...
You have a network of capacitors.
Well, all of a sudden, I've doubled the area of the ground plane, so all of a sudden, hey, the moisture went up. And so I had to redesign some things, and so I'm working on that redesign now. But I did, and I'll probably have that at a future one. But I've managed to come up with a redesign that is just as simple and just as cheap, just has one more component, which is a transformer, and a little tiny one. And although it uses a completely different mechanism for determining the capacitance.
Yeah.
But what's cool is that it uses a very simple protocol that you can hook up like 20 of them in a bus, and you can sense them, have it come back. Originally, I was using the one-wire protocol, and Maxim does not like that.
No, they really don't.
They still have...
We actually had a discussion because we know some people who are trying to do a one-wire protocol, and they're like, we like one-wire, and we're like, don't use one-wire. Also, Maxim is killing off like one-wire devices slowly but surely. They had a larger collection of them, and now they don't. So I think even though it's like their thing,
That's
they're
double
actually,
bad.
They're not going to destroy it, I think, but they're kind of minimizing it because I think they had this vision of like, oh, everything's going to be one wire, but in the end, like, people just want to use I2C.
Yeah.
So other than their temperature sensors and like a couple of other like little things, like I remember seeing, because I was looking through their thing, and a lot of them said like discontinued, discontinued, discontinued.
You can't buy it and you can't use it. Other than that, it's great.
When does the patent on that expire? Do you know?
In, I believe, 2 more years.
Okay.
But there's a different bus called Fox Bus, so the patent on one wire covers basically the first layer, right? Layer 1, just the physical layer. It doesn't cover the actual protocol, just the signaling. So if you use a different mechanism, then you can still use that protocol, which is convenient. So there's this other protocol that uses one wire. It's called Foxbus, that supposedly has much better noise resistance, and it works over longer distances, and you can actually use the one-wire protocol over it, the layer 2 of it.
Yeah.
And so that's what I'm eventually going to be using. I had a little trouble getting it implemented, but that shouldn't be a problem once I get a little bit more time.
Okay.
What is the stuff that you're coating the circuit board with? It looks like some type of substance, some stuff.
So I tried lots.
Yeah, I was going to say, it looks like you went through some experiments.
So the first thing I tried was Plastidip.
Yeah.
And Plastidip is unfortunately a little bit porous. So as much as I love Plastidip didn't work.
Why do you have to coat anything? Why not just use the PCB coating?
So I could, and there's that, just use the green coating there, but I figured I wasn't sure what the properties of that would be. That's not designed to withstand weathering, right? So, or being put in the soil. I wasn't sure how well that would do. Unfortunately, I put useless vias in here. I didn't quite realize that they would not be a good idea to put them in there. So.
But you don't need to. You only need one layer, really.
Yeah, I didn't need vias. So in a future design, I'll be taking them out. But the next thing I tried was epoxy. And so what happens is that I stick them in the soil, and I get a good reading. And then, over time, the reading would just get higher and higher and higher. And then I'd take it out, the reading would go down, and then I'd stick it in. Like, immediate changes in soil moisture, I would be able to detect. But eventually, it would just absorb water. And I tried, this was a marine epoxy. That didn't work either. What I'm going to do next time is actually have 2 prongs so that there's no shared material in between them. And so that should work. It doesn't, and it won't matter if they absorb some water or not.
I see. Yeah, that doesn't make. What about conformal coat? That's the most common thing. That's the most common conformal coating that you put on PCBs.
I have no idea. I haven't.
I'll pick up some spray conformal coat available at every fine electronics shop, and you're in the Bay Area, so you could probably actually pick it up at a real shop. But conformal coat is what they stick on stuff when they put it outside. That's what external PC. That's the weird gooey stuff that's on PCBs that are outside. Like if you ever get light fixtures that are, or solar stuff that's meant to be outdoors, it's all gummy. That's what they use. And
I think the biggest problem, though, is that it's just very sensitive to detecting the differences in capacitance, and it just absorbs just this little tiny amount, and that changes the electrical properties just ever so slightly.
Also, you could also probably just dunk it in water. If it's coated and it's single-sided, it's fiberglass and epoxy.
Yeah, well, I thought about actually having have a layer in between, I use a 4-layer and then actually have the sensors be on the inside.
Yeah.
I've thought about that, and I just haven't gotten around to it.
That's probably a good solution too, because then especially if you give yourself a little bit of space, so it's 2 prongs, and then you have a thin line in the middle. So
that's what I think is going to be ultimately the solution.
Well, just a question. I don't think PCBs absorb water, but if you conformal coat them, then they definitely won't. And then maybe if you have all these things, then it won't be as sensitive. I don't know.
This is a cool project. And then on the top, is that an Ethernet jack, basically?
So this is actually just the ISP connection, which also happens to be the same connection that I'm using to connect them up together. So I just...
oh, cool.
Plug them in that way, and then they go in. Although in the next version, I'm probably going to have some sort of waterproof thing on it.
Yeah.
Yeah, that's
for it to
waterproof cables. Check them out.
And the other thing that I put on the shelf for recently, but I'm getting back into it now, is this is a prototype light switch that is going to that works like a touch panel, so that you know, you press on the top to turn it on, you press on the bottom to turn it off. You can drag down to dim, drag up to undim, and it's got basically an XB connector on the back here. Got some other contraption there, and it's got power module here and then a load module here, and I actually got it working pretty well. I don't, unfortunately, I don't have a isolated power outlet near me, so I'm not going to plug it in right now so I don't die. But it's starting to actually get progress now. I can actually detect the position of this on the finger, change loads. Got a really simple power supply here for that's I can get about 30 milliamps out of it without it being something terribly complicated. And so that's the other thing that I've been working on.
That's super cool, and you could potentially have room lighting. So when you tap a different section of the light switch, you could maybe turn on different lighting throughout.
Yeah, I'd like to have gestures. You know,
Yeah.
so like if you know, maybe I could make it so that I could. Well, the primary thing I was thinking about using gestures for was for passcodes. You know, like strike down twice and then, you know, strike up, you know, once, you know, allows you to, you know, actually change the lighting for some reason. If you
like different lighting patterns you could have, like, you know, you could fill out number 3 and that would be like dim and do something else or like whatever. That's super cool.
On this particular design, I don't have horizontal, just vertical. But if at some point, I could, I'll get to that. And what I'd like to do is, you know, have these switches everywhere, and they don't all have to have loads on them. They could actually control other things, like, say, the locks on the house or whatnot. So, yep, that's the other project and I've been working on that project for years. Just a matter of there's no time.
Yeah.
If someone would, if this, I would love for this to be my full-time job, but it's not.
I thought this was your full-time job.
Oh no.
Those lawns aren't going to water themselves.
You should start your own nest.
Apparently they are going to water.
Competitor.
The future
But
of
with
light
light.
switch.
The future of the light switch.
Light switch are never going to be the same.
I would love to, but my employer is just not interested in that field at the moment.
Not
yet.
Not yet.
And if they were, they wouldn't tell you.
Yeah.
Well, see, that's the problem, right? If they get into it, it's.
I know. I'm surprised. I'm actually surprised they're letting you do what you're doing, but maybe they don't know.
They've been calling Lemoore, so I think
They've been calling me up on the phone.
I think lots of cool stuff is going to happen. Okay.
Okay.
And then we're going to end show and tell, and we're going to start up Ask an Engineer.
That's right.
At 10. Okay. Well, thank you so much, Robert. Those are awesome projects.
Thank you, everybody.
Thank you, Kevin.
Awesome.
Thank you, Jeremy.
Bye.
Thank you, Harry.
Bye. Bye. See you soon.
Bye.
Okay. Ask an Engineer.